projects. In this video, we are going to explain about a project titled A Novel Method to Predict Knee Osteoarthritis Progression on MRI Using Machine Learning Methods. So now coming to the introduction part, the potential impact of this method is substantial. It could be enable earlier and more accurate identification of patients at higher risk of OA progression, allowing for timely interventions and personalized treatment strategies. Furthermore, by providing clinicals with a reliable tool for assessing disease advancement, this method could facilitate more informed clinical decision making and better patient management. Central to this innovation is the training phase, where ML models are fed a diverse array of labeled MRI data along with corresponding OA progression information. As these models learn from the data, they begin to recognize subtle associations between image features and disease advancement. So now coming to the objective part for this project is to introduce a cutting-edge method that leverages ML algorithms to predict knee OA progression based on MRI data. By addressing the challenges of accurate prediction and early detection, this method aims to revolutionize the field of OA management, offering the potential to elevate patient suffering, enhance healthcare strategies, and pave the way for more effective interventions. The success of this approach hinges on the model's ability to identify subtle changes in joint structures, cartilage thickness, and other relevant indicators that contribute to OA progression. Another vital objective is to enhance the predictive accuracy of the proposed method over time. As the ML models encounter more data and continue to learn, they are expected to refine the understanding of the underlying disease patterns. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE and that is 3.7 version is required. So now coming to the methodology part, first upload OAI knee MRI dataset. This step refers to the initial step of obtaining the OAI, that is Osteoarthritis Initiative Knee MRI dataset, which contains a collection of magnetic resonance imaging, that is MRI scans of knees. The OAI dataset is a widely used resource for researching knee osteoarthritis and related conditions. Second, read dataset and build model. After reading the dataset, the next step involves reading and pre-processing the data. This includes loading the MRI images along with any accompanying clinical information into a structured format that a machine learning model can work with. Third, run naive-Bayes algorithm. It is a probabilistic machine learning method commonly used for classification tasks. It calculates the probability of a certain class based on the features of the data. Running the naive-Bayes algorithm involves training it on a proportion of the data set and then evaluating its performance on another proportion to assess how well it can classify or predict outcomes based on the given features. Fourth, apply PCA. PCA stands for Principal Component Analysis. It is a dimensionality reduction technique used to transform high-dimensional data into a lower dimensional representation while preserving as much of the original variance as possible. Applying PCA involves projecting the dataset onto a new set of orthogonal axes, that is principal components, that capture the most important information in the data. Fifth, run SVM algorithm. Here SVM stands for Support Vector Machine, a popular machine learning algorithm used for both classification and regression tasks. SVM seeks to find a hyperplane that best separates different classes in the dataset. Running the SVM algorithm involves selecting appropriate parameters, training the model on a subset of the data, and then evaluating its performance on another subset to determine its accuracy in classifying or predicting outcomes. Sixth, run random forest algorithm. Random forest is an ensemble learning method that combines the predictions of multiple decision trees to produce a more robust and accurate result. Each decision tree is built on a different subset of the data, and the final prediction is made by aggregating the predictions of individual trees. Running the random forest algorithm involves creating an ensemble of decision trees, training them on the dataset, and evaluating their collective performance. Seventh, run ANN algorithm. ANN stands for Artificial Neural Network, a class of machine learning algorithms inspired by the structure and function of biological neural networks. ANN is particularly effective for complex tasks like image recognition. Running the ANN algorithm involves designing and training a neural network architecture that suits the dataset's characteristics. Training involves adjusting the network's parameters to minimize the difference between predicted and actual outcomes. 8th, accuracy graph. The accuracy graph is a visual representation of the performance of different machine learning algorithms. It typically shows how accurate each algorithm is in making predictions or classifications on the given dataset. This graph helps compare the performance of various algorithms and identify which one performs best for the specific at hand. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as backup with dataset information. Here again we are containing some folders over here, and these are all the datasets over here, and the folders are also containing the datasets over here. Another folder is named as dataset. In this again we are containing some .txt file which are the dataset over here. And here need change prediction is a Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. So now click on upload OAI knee MRI dataset button to upload either lateral.txt or medical.txt file. So here I am selecting this lateral.txt file over here and click on open button. So here you can see that the file has been uploaded over here, and now click on read dataset and build model button to read values from uploaded datasets. So after reading the dataset, now click on apply PCA button if you want to run algorithms with PCA. If you don't want to run with PCA, then directly click on algorithms button. Here I am not running PCA, so directly click on over the run SVM algorithm button to get SVM model details. You need to wait for some seconds to get the results. So here on this screen you can see that the total features are 42 and the PCA concept is 35. So now click on run SVM algorithm button over here. So here on this screen you can see that we have got the accuracy is 46%. Similarly, we click on run random forest algorithm button to get the results. So here on this screen you can see that we have got 95% accuracy, and now click on run naive Bayes algorithm button over here. So here you can see that we have got 81% accuracy, and now click on run ANN algorithm button to get the details. So here we can see ANN accuracy is 97%, and you can compare precision recall and F measure between ANN and random forest, and you will find random forest which give better performance. So now click on accuracy graph button over here to get the graph. Here you can see that the x-axis represents the algorithm names over here. So here you can see that the last graph is showing the better performance among all the graphs. Now closing this graph. So now coming back to the conclusion part, in essence the development of this novel method represents a significant step forward in the field of OA management. By harnessing the capabilities of ML and medical imaging, it offers a pathway to more precise, personalized and timely interventions, ultimately improving patient outcomes and contributing to the advancement of musculoskeletal healthcare. As this research paves the way for further study and refinement, its potential impact on the lives of those affected by knee OA remains both promising and exciting.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.